The discovery of Pluto was not planned, but rather a mathematical mistake that completely astonished the entire world. Astronomers were in search of a predator millions of kilometers away that was pulling planets out of their regular paths. But when they finally arrived at the exact target, they didn't find a powerful predator. Instead, they encountered a tiny traveler. Today, we will look into how the discovery of Pluto turned out to be a mistake by astronomers, and why we ultimately pushed it out of the category of major planets. Welcome back to another video on Ancientgraphy. The story of Pluto actually begins 150 years before its formal discovery, when our solar system's seventh planet, Uranus, was discovered in 1781. However, astronomers noticed a strange issue in Uranus's orbit. When they calculated its path based on the mass of Uranus, it became clear that it was not moving along its orbital path the way it should according to Newton's law of gravity. At that point, experts assumed that either Newton's law of gravity was incorrect, or there was another planet existing beyond Uranus that was pulling and diverting it from its original course. Their hypothesis turned out to be completely accurate. At the exact point where Uranus was showing this behavior, they found a second planet, the eighth planet of our solar system, known as Neptune. This was a monumental victory for science. However, the problem was still not completely solved because even after finding Neptune, Uranus was still wobbling slightly. Based on Neptune's mass, Uranus was diverting even more than it theoretically should have. This could only mean one thing. There was a massive and heavy planet lying even further out than Neptune that was disturbing both of them. This hypothetical and heavy celestial body was named Planet X, and for the next several decades, astronomers dedicated themselves to tracking it down. To search for Planet X, an American astronomer named Percival Lowell built a dedicated observatory in Arizona, which is called the Lowell Observatory. But just a few years later, in 1916, Lowell passed away without ever finding Planet X 13 years after his death. The immense responsibility of hunting down Planet X was handed over to a 23-year-old named Clyde Tombaugh. His job was incredibly difficult and exhausting. He would take photographs of the exact same patch of the night sky across different days, and then meticulously compare them. If a shining point of light changed its position relative to the surrounding stars, it meant that it wasn't a star, but a planet. On February 18, 1930, Clyde noticed a tiny dot shifting its position between two photographs that had been captured back in January. Further investigation confirmed that this was indeed Planet X, the very body the world had been looking for. The name for this new planet was suggested by an 11-year-old British girl. She believed that because the planet was so distant and locked in total darkness, it should be named after the Roman god of the underworld, Pluto. But nobody knew back then that in the coming years, Pluto's status as a planet would be put in jeopardy. When Pluto was first spotted in 1930, astronomers did not possess highly powerful telescopes. Therefore, they assumed that it must be a massive and heavy planet to be capable of disrupting the orbits of Uranus and Neptune. However, as the years progressed and telescope technology drastically improved, the calculated mass of Pluto kept shrinking in the eyes of scientists. In 1930, Pluto was assumed to be roughly equal to the size of Earth. In 1948, fresh calculations suggested it might only be about the size of Mars. But the real truth about Pluto came to light in 1978 when Pluto's moon, Charon, was discovered. Here, something occurred that completely baffled astronomers. According to physics, if you know the exact orbit and orbital speed of a planet's moon, you can precisely calculate the weight of that planet. When astronomers analyzed Charon's orbit and speed to calculate Pluto's mass, they were completely stunned. Pluto turned out to be so light that it was physically impossible for it to disturb or divert the orbits of giant planets like Uranus or Neptune. Now a fresh debate sparked. If Pluto was really that tiny, then what had been disturbing the orbits of Uranus and Neptune all along? This debate probably would have continued endlessly, but in 1989, humanity's first interstellar probe, Voyager 2, flew past Neptune. Thanks to Voyager 2, we discovered that Neptune's previously recorded mass was completely incorrect. Yes, indeed. Based on a very slight variation in Voyager 2's velocity as it flew past, the true gravitational pull of Neptune was finally measured, and it turned out to be 0.5% less than older calculations had stated. When this updated and accurate mass was factored into the mathematical models for Uranus's orbit, The strange planetary wobbling that had baffled astronomers for over a century instantly vanished. So what this means is that the discovery of Pluto was nothing short of a complete coincidence. Or, you could even say that Pluto was discovered entirely by mistake. From 1989 onward, school textbooks around the world taught Pluto as the smallest and coldest planet in the solar system. Most of you probably grew up reading about Pluto as the official ninth planet. But then, in 2006, something happened that severely threatened the existence of this ninth planet. In 2005, experts discovered another celestial body located even further away than Neptune, which they named Eris. The weight of Eris was significantly greater than that of Pluto. This left astronomers with two choices. They could either accept Eris as the 10th planet of the solar system, and subsequently grant planet status to hundreds of other similar bodies being discovered out there, or they could change the official definition of what a planet actually is. Because observation technology was advancing rapidly, and bodies similar to Pluto and Eris were constantly being found, they decided to redefine the word planet. In 2006, the International Astronomical Union, IAU, established 3 mandatory conditions for any celestial body to be classified as a planet. The first condition was that the body must orbit around the Sun, which Pluto successfully does. The second condition was that it must possess sufficient gravity to pull itself into a nearly round shape. Pluto passed this condition as well. However, the third condition put Pluto's entire planetary status in extreme jeopardy. That rule stated that a planet must be the gravitationally dominant object within its own orbital zone, meaning it must have cleared its neighborhood of other smaller space rocks and comets. While Pluto does orbit the Sun, it resides in a very distant region of space known as the Kuiper Belt. This belt is home to countless small, icy rocks and comets. For any planet to clear asteroids and comets out of its orbital path, it must possess an immense amount of gravity. To have that much gravity, it needs to have a very large mass. Pluto's total mass, however, is a mere 0.2% of Earth's mass. This is exactly why it is unable to dominate the comets sharing its orbit. To put it in simple terms, Pluto's gravity is not strong enough to either pull these millions of comets toward itself to absorb them, or to gravitationally sling them completely out of its orbit. Because of this failure, in 2006, the IAU officially removed Pluto from the category of major planets and reclassified it into the category of dwarf planets. But this does not mean Pluto is gone or irrelevant. Instead, it is now considered the undisputed king of its new category. The Kuiper Belt, which is often referred to as the junkyard of our solar system, is where Pluto continues to make its presence felt, shining brightly among thousands and millions of comets. Even though it is physically smaller than our own moon, size does not matter at all in Pluto's case. This tiny world held so many deep secrets inside it that it left astronomers completely amazed. The entire credit for unveiling these hidden secrets goes to a spacecraft named New Horizons. Launched by NASA in 2006, this mission was by no means easy. New Horizons was a robot roughly the size of a piano, sent by humanity into the void across a distance of 3 billion kilometers. Pluto is located so incredibly far from our planet that even a beam of light takes roughly 5 hours to travel that distance. This is why NASA mounted the probe on top of Atlas V, the most powerful rocket available at the time. When this rocket launched, it successfully crossed the moon's orbit in just 9 hours, whereas the historical Apollo missions took a full 3 days to reach the moon. Yet, even that immense speed wasn't enough to reach Pluto in a reasonable time frame. A year into its journey, as it neared Jupiter, it used the massive gravity of the giant planet to perform a slingshot maneuver, drastically boosting its speed. After traveling for another 8 long years, the moment everyone had been anxiously waiting for finally arrived in 2015. New Horizons had successfully arrived close to Pluto. For the first time in human history, we were laying eyes on the true face of this ninth planet. In those historic photographs, 2 highly distinct bright bodies were captured, Pluto and its primary moon, Charon. The relationship between these 2 bodies is incredibly unusual. While our moon is significantly smaller than Earth, Pluto's moon is roughly half the size of Pluto itself. They are so close to one another that their rotational movements have become tidally locked. This means that if you were to stand on the surface of Pluto and look up at Charon, you would always see only one side of the moon, and it would never set or move across the sky. Similarly, On the far side of Pluto, the moon would never be visible at all. Pluto and its moon exert such a strong gravitational pull on one another that their mutual center of gravity, the barycenter, does not lie inside Pluto at all, but rather in the empty space between them, which looks quite extraordinary to observe. But the real magic truly began when New Horizons started beaming high-definition photographs of Pluto back to Earth. Prior to that day, everyone assumed that because Pluto is extremely cold, it would turn out to be a highly boring, crater-pocked, lifeless rock. However, the close-up images revealed that Pluto is actually remarkably colorful. It turned out to be a stunning combination of blue, red, white, and orange hues. The very first feature that captured everyone's attention was a massive, prominent heart shape visible on Pluto's surface. This perfectly formed natural heart-shaped region is scientifically named Sputnik Planitia. The most fascinating characteristic of this planetary heart is that it is entirely smooth and completely free of impact craters. This region is covered in nitrogen ice, the exact same nitrogen that exists as a super-chilling liquid on Earth. Out there, the extreme temperature of -229 degrees Celsius has frozen that nitrogen completely solid. The heart-shaped plains feature strange polygonal patterns, which serve as a clear sign that Pluto's internal core is still active and warm. Beneath the surface, nitrogen ice warms up, melts, wells upward, and then freezes over again upon reaching the top. This continuous convective movement is precisely what keeps the entire heart region fresh, smooth, and entirely unblemished by crater impacts. Furthermore, Pluto possesses a very thin atmosphere composed of a mixture of nitrogen and methane gases. When ultraviolet rays from the sun react with the methane in the atmosphere, a chemical reaction occurs that generates an organic material called tholins, which is reddish-brown in color. This organic material falls down onto the surface like snow, which has given a massive portion of Pluto its distinct reddish and orange tint. New Horizons also discovered something on Pluto that was previously considered almost impossible to imagine: cryovolcanoes. Yes, ice volcanoes. You have likely seen volcanoes on Earth that spew molten fire and rock, but on Pluto, there are active volcanoes that erupt with ice. When these cryovolcanoes erupt, they do not release hot lava. Instead, they ooze a freezing slush made of water, methane, and ammonia. Due to the presence of internal heat within Pluto, planetary scientists strongly believe that beneath its thick outer icy crust, there could be vast liquid water oceans. Just as a thick layer of ice prevents the water underneath from freezing solid in the Earth's Arctic regions, Pluto's massive layer of solid nitrogen ice might be acting as an insulating blanket, preserving deep reservoirs of liquid water or liquid nitrogen underneath. This was the incredible story of a lonely traveler that we managed to discover, but could never truly call our own. Admittedly, Pluto failed to meet the rigid planet criteria that we humans established, but its physical presence was always out there in the Kuiper belt, and it remains there today, completely independent of any human label or recognition. We hope you will show your support by liking and sharing this video from Ancientgraphy. Thank you so much for all of your wonderful and loving comments. See you all in the next spectacular video.